Hello everyone. In our last class, we started with combination, right? So, what was combination? The number of ways to select a few things, right? So, if I want to select, for example, eight members are registered, and I want to select five out of them. Since I want to form a committee, it doesn't matter whose name I call out first and whose name I call out second. What only matters is just selecting the five people. Since the job here is only about selection, we can have 8C5. Out of 8, choose 5 people. Out of 8, choose 5 people. So the formula for NCR was factorial n minus r factorial r. So this would be factorial a, 8 minus 5 factorial and 5 factorial. So 8 into 7 into 6, 5 factorial gets cancelled. So 8 into 7 into 6 upon factorial 3, which is 6. So 8 sevens are 56. That was our answer. So we use combination only in scenarios where it doesn't matter the position, it doesn't matter the arrangement. What matters only is selection, is how to choose them. In that case, we use combination. So we learned several formula. The first was NCR formula. Second, we also learned that like 8C5 will be same as 8C, 8 minus 5, 3. NCR is same as NC and minus R. 13C3 would be same as 13C, 13 minus 3, 10, which makes it sometimes easier for us to calculate. There are also certain tricks that we use to calculate combination. Tricks to calculate combination. First, NC0. Out of N, choose 0 people. Out of N, choose 0 people. That means don't choose anyone. So you don't need to multiply any number. So their answer would be 1 divided by factorial 0. Factorial 0 is what? Again 1. If I have NC1, since I have 1, that means multiply only one number. And the first number that I'm allowed is to have N divided by factorial 1, that is 1. Third, NC2. Since there is 2, so I'm going to multiply two numbers. First will be n, the next will be a number smaller than that, divided by factorial 2, that is 2. Fourth, NC3. Since it is 3, so multiply three numbers. n, n minus 1, n minus 2, divided by factorial 3. So for example, if I have to calculate 10C13, sorry, 10C7. First, I can make it a little smaller. 10C, 10 minus 7 is 3. Since there is 3, we need to multiply three numbers. 10, 9, 8 divided by factorial 3. So 720 upon 6, that makes it 120. Suppose if I have NC3 equals 60. Since it is NC3, I can multiply 3 people and divide it by factorial 3. So n minus 1, n minus 2, factorial 3 is 6. This was 10. So n minus 1, n minus 2, this is 60. Since on the left hand side it is a product of three numbers, I can write 60 as 5 into 4 into 3. The largest number on the left hand side is n and the largest number on the right hand side is 5. So n will be 5. We can use these tricks to make our calculations simpler comparatively, right? I hope you all understood. Now we'll move on to different varieties of sums, handshakes, lines, triangles, parallelograms, and all those questions. Let's start with handshake. Suppose a party has three people, A, B, C. And it is compulsory for everyone to meet and greet each other, right? So first A meets with B, A meets with C. Now, since A has already met B, so B again does not need to put up an effort and come back to meet A. It doesn't make sense, right? A and B has met, no matter who came to whom. B, A and B has met, A and C has met. We are left with B and C. We are left with B and C. So all the three people have met each other, right? So between A and B, there will be one handshake. Between A and C, there will be one handshake. Between B and C, there will be one handshake, right? So in total, in a party of three people, there will be three handshakes. So instead of counting number of handshakes, instead of counting here number of handshakes, yeah, I can also say that it is same as equal to number of pairs. It is same as number of ways of selecting two people. So how many people did we have in total? We had three people, A, B, and C. Out of those three, how many did we want? We wanted two. So out of three, how many ways are there to choose two people? It will be 3C2. It will be 3C2. 3C2 is same as 3C1, which is 3. And our answer is also 3. So that means in order to count handshake, we only count how many ways are there to select two people, right? Similarly, if I would have had here four people, A, B, C, D, and I wanted to count a number of handshakes, then I would have written A meets with B, A shakes hands with C, A shakes hands with D, B meets with C, B meets with D, C meets with D. So in total, we have seen that there are six handshakes, six pairs, right? Six ways of selecting two people. So number of handshakes again here can also be out of four people, choose two. So 4 into 3 divided by factorial 2, that is 6, which is also our answer. That means number of handshake, if there would have been 5 people, would be 5C2. Number of handshake, if there would have been 7 people, would be 7C2. Number of handshake, if there would have been 10 people, will be 10C2. Number of handshake, if there will be n people, will be NC2, right? So number of handshakes will be NC2. Similarly, if I say that there are 3 points, there are 3 points, A, B, C. What I'm counting is number of lines. Number of lines. So from A to B, draw a line. From A to C, draw a line. Now, since I've already drawn a line from A to B, I don't need to draw it again from B to A. Since A, B and B are considered same here, that's why it's a question of combination and not permutation, right? Now what we are left with is a line from B to C. So in total, we see that there are 3 lines. So isn't it very similar to handshake? Number of pairs, number of lines, number of handshakes are both basically number of pairs. That is number of ways of selecting two people. Number of ways of selecting two people. So if I have 3 points and I want to select 2 points, so out of three, choose 2 points for a line. Out of three, choose 2 points for a line. So answer would be same as 3C1, that is 3. If I would have had 4 points, A, B, C, D, then the lines will be A, B, A, C, A, D. Again, B, A, B is not needed. So B, C, B, D, then C, D. So in total, I have 6 lines which we can see geometrically. So again, in case of lines, I'm basically forming pairs. I'm basically making a selection of two people. So again, from 6 points, how can I select two people? From 6 points, how can I select two people? So out of six, choose 2 points. Out of six, choose 2 points. So 6 into 5 divided by 2. That is, sorry, out of 4 points, no? Out of 4 points, choose 2. So 4 into 3 divided by 2, that is 6. So if I have 3 point, number of lines is 3C2. If I have 4 points, number of lines is 4C2. If I have 7 points, number of lines will be 7C2. If I have 10 points, number of lines will be 10C2. If I have n points, number of lines will be NC. Similar to this, if I want triangle, for triangle I'll be needing 3. So instead of 2, now choose 3. NC3. It will be NC3. So formulas. First, number of handshakes in a party of n people, NC2. If there are n points, normal scenario, no fancy thing attached to it, no three of which are collinear, then number of lines would be NC2. Number of triangles would be NC3. Number of lines would be NC2 and number of triangles would be NC3. Now imagine, I'll come back to this formula. Imagine I give you 4 points, A, B, C, D. And we know that out of 4, to make lines, we need 2 points. So 4 into 3 by 2, that is 6. So in total, there should be 6 lines. AB, AC, AD, BC, BD, CD. AB, AC, AD, fine. But now I don't need to have BC, CD, and then BD again, right? Because when I take BC and CD and BD, or there is repetition. If I would have taken only BD, then BC and CD would have been included in it. If I've already drawn BD, why do I need to draw again BC and CD? There's no point. That means in this question, what I'm saying is out of 4 points, 3 are collinear. Out of 4 points, 3 are collinear, right? So in total, if I first say I got 6 lines, but that's wrong because I've counted a few of the lines extra. Which are the lines I've counted extra? The ones that the collinear points are forming. How many points are collinear? 3. Those 3 collinear point will give me how many lines? 3C2. The 3 collinear points B, C, D will give among themselves 3C2, that is 3 lines. These 3 lines. So what will I ask is from the total, remove all of them. From the total line, remove all of them. Yes. Now what should I do? Now just take the longest line. Just take the longest one line. So add 1 to it. So basically from total 6, I removed all the lines that the collinear were forming and then added the longest one to it, which gave me 4. So in total, if you can see, AB, AC, AD and BD, there are a total of 4 lines. There are total 4 lines. So what we do in collinear is, from all the lines first, we remove the collinears, all the slides. Every single line that the collinear forms among themselves, we remove everyone. And what we do is, after removing all of them, we just take the longest one out of it. Because if I take only the longest one, the smaller ones are counted within it. There's no need to count again. So if I would have had 10 points, then total number of lines that will be formed is 10C2. But if 6 are collinear, then those 6 points in among themselves will give me a lot of lines which are not necessary. So these 6 points among themselves will give me 6C2 lines. So I'll remove all of them. And once I remove all of them, what will I do is I'll just count the longest one. Okay. So 10C2 is 10 into 9 by 2, 45. 6C2 is 6 into 5 by 2, 15, and then add 1 to it. So 31. 31. There will be 31 lines. If there would have been n points, m of which are collinear, then number of lines will be total minus collinear plus 1. Total minus collinear plus 1. So here, if m points are collinear out of a total of n points, then number of lines would be total minus the collinear plus 1 for all of them. Plus 1 for all of them. Plus 1 for all of them. Now, in this case, similarly here, if I would have been forming the triangle, I would have taken all the triangles 4C3. But the points that are collinear, these 3 points in our case, will not give me a triangle. So these 3 points will give me how many triangle? Only one triangle. I'll remove the triangle. Now, do I need to add 1 to it like a line? No, because all the collinear points, yes, give me a longest line. But no, they don't give me any triangle. So, in case of collinearity, while forming the triangle, from the total number of triangles, we remove the triangle that we have mistakenly counted from the collinear points and we just remove them. Because they are not triangles, they are basically only lines. So, I can't count them in triangle. So here 10 points. So number of triangle would have been 10C3. But these collinear points among themselves, if I would have selected 3 of them together, those are not giving me a triangle because they're lying on a flat surface. They're lying on a single straight line. So I would have written them in a triangle, but those are wrong. So from total, I will remove those points. From total, I will remove those points. So if I'm talking about triangle, if I'm talking about triangle, then it will be total minus all the collinear ones. Total minus all the collinear ones. Yes. Now, supposingly, I give you a quadrilateral. Quadrilateral means there are 4 vertices, that is 4 points, and there are also 4 sides. So, if you give me 4 points, out of 4 points, how many lines can be formed? Out of 4 points, to form a line, we have 4C2. That is 6 lines. So if I have 4 points, say A, B, C, D, the lines will be A, B, A, C, A, D, B, C, B, D, C, D. Right? So out of, if I have a quadrilateral, there are 4 points. So out of 4 points, we form 6 lines. But out of those 6 lines, AB, BC, CD, and AD are the boundaries itself, are the sides itself, because it will also have 4 sides. So if I remove those 4 sides, I'll get the 2 diagonals. I'll get the 2 diagonals. So out of 4 points, first I found out all the lines. That is 4C2, 6 lines. Since there were 4 points, there will also be 4 sides. So out of those 6 lines, we remove the 4 sides that the quadrilateral has. The remaining 2 are the diagonals. Are the diagonals. If I have a pentagon, pentagon means 5 vertices and 5 sides. So out of 5 vertices, I will have 5C2, 10 lines. I will have 10 lines. But out of those 10 lines, 5 are its side itself. So remaining 5 are the diagonals. 5 are the side itself. So remaining 5 are the triangles. If I have a hexagon, that means 6 vertices and 6 sides. So out of 6 vertices, I have 6C2 number of lines. I have 6C2 number of lines. So I have in total 6 into 5 by 2, 15 lines. But out of those 15 lines, 6 are the boundary. The remaining 9 will be the diagonals. So what we do is from all the vertices, we first calculate all the lines. And then from all the lines, we remove what? The number of sides that the figure has. The remaining lines will give us the diagonal. So if there are 10 vertices, then there will be 10 sides also. So those 10 vertices will give us 10C2 lines. From those 10C2, which is 45, we will remove the 10 sides. The remaining 35 are the diagonals. So number of diagonals in a polygon of n sides is from n select 2 number of lines and then from here remove n, which are the sides itself. This will give you the diagonals. This will give us the diagonals. Now, supposingly I give you 4 horizontal lines, H1, H2, H3, H4, and I give you 5 vertical lines, V1, V2, V3, V4, and V5. So there are 4 horizontal lines and 5 vertical lines. What I want is a number of parallel. See, right now I've given the lines at a 90 degree. So I can also ask you rectangle. If I would have given you the lines as slanting, I would have given you parallelogram. So whether I'm forming a parallelogram or rectangle, depends upon the given lines. If the lines are given perpendicular to each other, I'll get a parallelogram, rectangle, or I'll get only a parallelogram. So number of parallelogram slash rectangle. Now, in order to form parallelograms or rectangles, what I want are 2 horizontal lines and 2 vertical lines. Any two will work, right? If I would have taken H1 and H3 and these 2 vertical lines, V1, V5, yes, it's a rectangle. If I would have taken this, yes, it's a rectangle. If I would have taken this, yes, it's a rectangle. So whichever horizontal and vertical line I take, I'll always get a parallelogram or a rectangle. So out of 4 horizontal lines, I need to select 2. Out of 4, choose 2. And out of 5 vertical lines also, choose 2. And I want both of them to form a parallelogram or a rectangle. So 4C2 multiplied by 5C. So horizontal C2 multiplied by vertical C2. So 6 into 10, there will be 60 rectangles or 60 parallelograms here. There will be 60 rectangles or 60 parallelograms here. Now, when it comes to square, there is a trick. Okay, there is a trick. How to do that? Imagine that all the lines, the vertical as well as the horizontal, are 1 centimeter apart. 1 centimeter apart. So when I'm going to form squares, the longest square that I can form is of 4 centimeter. See, vertically I have 4 centimeter, but horizontally I don't. So that's wrong. So that means, see here, 1 centimeter, 1 centimeter, 1 centimeter. So horizontally I can only go till 3 centimeter. So the maximum square that can be formed here will be of 3 centimeter. So if I want a 3 centimeter square, if I want a 3 centimeter square, I need to have 2 horizontal and 2 vertical lines which are at a distance of 3 centimeter. So horizontally, I only have one option, H1, H4. I have to take these 2 lines. Then only I'll get this length to be 3 centimeter. But when it comes vertically, either I can take V1 to V4. This will give me a square of 3 centimeter, right? I can have V1, V4, right? Or I can also have I can also have V2, V5. Then also I will have a square of rectangle 3 centimeter. V2, V5. That means the two squares that I have, the two squares that I can have, first one is this and second one will be this. These are the only two squares that I have to form for length 3 centimeter, right? So basically number of horizontal ways 1, number of vertical 2, multiply them. So there are two squares of length 3 centimeter. There are two squares of length 3 centimeter. So of length 2 centimeter. If I want my square to be of length 2 centimeter, I want horizontal lines which are 2 centimeter apart, and I also want vertical lines which are 2 centimeter apart. So horizontally, I have two possibilities, H1 and H3, 1 centimeter, 1 centimeter, or H2, H4, two possibilities. Vertically, I'll have V1, V3, 2 centimeter, V2, V4, 2 centimeter, V3, V5, 2 centimeter. So total 3 vertical possibilities. So in total, 2 into 3, 6 rectangles of length 2 centimeter. Let's see how. H1, H3, V1, V3. 1, 2, 3, 4, 5, and 6. These are the 6 squares that can be formed of length 2 centimeter. Now comes length 1 centimeter. That's the smallest one that can be formed. So for length 1 centimeter, I want two consecutive horizontal lines. So I can have H1, H2, H2, H3, H3, H4. Horizontally, three possibilities. Vertically, I can have V1, V2, V2, V3, V3, V4, V4, V5. Vertically, I have four possibilities. So 3 into 4, 12. You can see here 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the 21 centimeter squares. So in total, number of squares will be 2 plus 6 plus 12. So what we do here is, I had 4 horizontal and 5 vertical. The trick is, subtract 1 from both the number. 4 minus 1, 3, 5 minus 1, 4, multiply. Plus, again multiply 1 from them. So 3 minus 1, 2, 4 minus 1, 3, multiply. Plus, again multiply. 2 minus 1, 1, 3 minus 1 is 2. Here. If I again multiply, I'll get 0, so there is no point. This is how we get squares. So if I have horizontal and vertical lines, if there are n horizontal and m vertical lines, then first number of parallelograms or rectangles would be NC2 multiplied by MC. And if I want number of squares, I'll multiply 1 to both of them. Again, I'll multiply and subtract 1 from both of them. Again, till I get 0. Till I get 0. So what did we learn here? First, number of handshakes. Number of handshakes is, if there are 15 people, 15 C2, 10 people, 10 C2, 7 people, 7 C2. Number of lines, if there are 10 points, number of lines will be 10 C2, number of triangle 10 C3, if there is no problem of collinearity. If out of 10 points, 7 are collinear, Then the line will be total C2 minus collinear C2 plus 1. So 10C2 minus 7C2 plus 1. And if it is triangle, total C3 minus collinear C3. 10C3 minus 7C3. If we are talking about diagonals, so number of points, form all the lines and remove its sides. So 10 sides, 10 vertices. Out of 10 vertices, we get 10C2, 45 lines. Out of those 45 lines, remove the 10 sides, we get 35 diagonals. For if I have 4 horizontal, 4 vertical, the number of parallelogram or rectangle will be 4C2 into 4C2. And number of squares, keep on subtracting 1. 3 into 3 plus 2 into 2 plus 1 into 1 till we get 0. Till we get 0. So these are certain specific formula based question that we have in combination. So I think that's the end of combination. What we have left is a mixture of permutations and combinations and some varieties, okay, which we are going to do it in our next session. Thank you so much.